So of these laws, the one that I actually verbally say out loud the most, I believe, is Yagni. You ain't gonna need it. I say Yagni to myself or to others, even sometimes outside of the world of software. I'll just say the acronym to a friend and they'll be like, what? And I'm like, never mind. And we build things that we don't need all the time. And again, it kind of goes back to the idea of the cleverness or the I know what I'm going to need later mythos. It just lets us down so often. And so many times, we're just not going to need that thing that we're building.
It's funny you said Yagni. When you were saying there's one that I say a lot, I was thinking it's got to be Yagni because it's the same for me.
You saw it coming?
And it must be the same for any other engineer who's ever had to work on a feature where they're just thinking, is anyone really going to use this?
Bandwidth for Changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at Changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode Cloud servers. Head to linode.com/changelog. This episode is brought to you by DigitalOcean, Droplets, Managed Kubernetes, Managed Databases, Spaces, Object Storage, Volume Block Storage, Advanced Networking like Virtual Private Clouds and Cloud Firewalls, Developer Tooling like the robust API and CLI to make sure you can interact with your infrastructure the way you want to. DigitalOcean is designed for developers and built for businesses. Join over 150,000 businesses that develop, manage, and scale their applications with DigitalOcean. Head to do.co/changelog to get started with a $100 credit. Again, do.co/changelog. All right, welcome back, everyone. This is the Changelog, a podcast featuring the hackers, the leaders, and the innovators in the world of software. I'm Adam Stacoviak, editor-in-chief here at Changelog. On today's show, Jerry went solo to talk with Dave Kerr about laws that hackers live by. They unpack Hanlon's razor, Gall's law, Murphy's law, Kernighan's law, and too many others to mention, so let's just get into it.
So Dave, I found your repo on GitHub and it immediately caught my interest because it's one of those lists and there's all these awesome lists. This is a list not of links to other places, but this is a list of hacker laws. You describe it as laws, theories, principles, and patterns that developers will find useful. And I thought this is very cool. Let's talk through some of these laws. But first of all, tell us why you created this repo and where the idea came from.
Thanks. Yeah. I mean, I was kind of inspired by the awesome lists as well.
Yeah.
To be honest, I use them all the time, especially when I'm exploring a new technology. And to a certain extent, the idea for hacker laws as a repo came from that. Partly through my work as a consultant. So I'm an IT consultant. So I work with lots of different engineering teams and I work with lots of different organizations. And I would occasionally find myself kind of saying things like, this is kind of an example of Conway's law here, where what's happening is that the systems that are being built are reflecting the organization structure rather than actually adhering to, a sensible designed architecture, which sounds like the sort of smart-ass thing a consultant would say.
Yeah.
The more I thought about it, the more I would jot down certain things, like things I would hear, like the 80-20 rule, which I'd always read when I first started learning about programming, was that you spend 20% of your time writing like the first 80% of your code or your project, and then you spend the last 80% of your time doing the last 20%. And then realizing that, this has a name. This is called the Pareto principle, and it has a whole bunch of real world examples which it's based on. So I started jotting these down just on like an empty markdown file to start with. And then once I had a few pulled together, I put it on a GitHub repo, and every time I came up with an idea, I added it as an issue to kind of remind myself to come back to it. And then a couple of my colleagues made suggestions or said, hey, what about this? What about that? And then it kind of grew from there. And then I guess I was just through sheer luck, I tend to try and publicize when I've added a new law on Reddit or Hacker News. A couple of times, those posts have generated lots of discussion. So that's kind of brought a lot of traffic over to the repo, which then brought more ideas for laws and spirited discussion. So it kind of just grew from there, but it was fairly organic.
Yeah, today there's 15,000 stars. You got 55 contributors. It looks like I counted offhand 13 language or so. So it's been translated into other languages. So this is a very somewhat typical success story on GitHub. You know, you put a thing out there, you work on it over time, and over time, here comes the contributors. There's interesting conversation. Of course, because these laws are often referenced or thought about by hackers and developers, whenever you see a list of them, you're like, oh, this is awesome. You know, here it is. Here they all are. And what I found interesting as I went through this list is that a lot of my interpretations or like my memory of the particular things is slightly off of what they actually are, or can't be described by me in a way that it shows that I've internalized it. You know, sometimes you just memorize a phrase and you just kind of broad brush apply it. I actually wrote a post recently about why so many developers get dry wrong, because we did a show with the Pragmatic Programmers last year where they were rejiggering their book for the 20th anniversary. And one of the things they said is they had to rewrite the dry section because so many people misunderstood what they meant by don't repeat yourself. And that was a case where a lot of us can memorize the acronym and can just misunderstand what the actual point of what they were trying to say was. And it's in that case, it's a distinct point, but it makes a big difference what they meant by that.
I think that's completely it. And it's also sometimes the kind of intersection or overlap of these things. Like, I can't remember where it was that I saw a whole bunch of engineering principles kind of like printed out on the wall. And one of them was something like KISS is greater than dry. You know, it's like dry is great, but still keep it simple. So sometimes it's okay to repeat yourself, like if you're writing unit tests or whatever, and it does make the code more readable. You know, these are, and I think that's something that's kind of interesting about the laws, although some of them are called laws. One thing that I've tried to do is make it clear that I don't necessarily advocate that any of them are correct or not, but a lot of them only have limited applicability in the real world. And some of them are just kind of humorous or sort of slightly out there and a bit about organizations.
Right. And just to put a point on what the dry misunderstanding is for those who haven't heard this, dry, don't repeat yourself, is that every piece of knowledge should have a single, I'm reading it now, unambiguous, authoritative representation within a system. And the slight misunderstanding of that is don't repeat yourself. And so I just wrote some code and I don't want to repeat that code. Now, if that code is the writing down of knowledge, then in a lot of cases that applies. But we often take it to mean just don't type the same thing twice. But it's not really about that. It's about having a single place for each piece of knowledge in the system. And that distinction does make a big difference because we tend to prematurely dry up our code in a place where it doesn't actually make sense. You're not actually repeating any knowledge, you're just repeating procedures. So slight distinction, but big difference in practice.
And I think dry is a really good example of that, because I see it even in code editors nowadays when you've got things like static analysis tools that will say repeated lines. And unit testing, I think, is a really good example where, to me, a well-written unit test, I can look at it in isolation and understand how it's setting up its expectations, what it's executing, and what it's kind of asserting.
Right.
But if you were to make all of that unit test kind of scaffolding dry, you'd end up with a whole bunch of helper functions and stuff like this. And sometimes that's useful, and sometimes it does make it more readable. But actually, the kind of authoritative source of truth is probably the function that's under test itself. And the unit tests are really there as a scaffolding or an assertion framework. So it's a really interesting one, dry.
Yeah, so we thought for this conversation, so dry, one of them, of course, I wouldn't say there's hundreds of laws and principles, but I think there's a few dozen. We obviously don't have time to talk through them all, and I find some more interesting than others. I'm sure, Dave, you find some more interesting than the others. We thought we would just kind of ping pong back and forth, talk through some of these laws and principles, the ones that maybe come to mind often for us and that we think are generally applicable and interesting for folks. Of course, everyone will have their own take on which ones are good, better, best. But if I had to ask you, Dave, like what's the one that you think about the most or that you apply the most in your day-to-day work of consulting or programming, what would you respond with?
I think in the world of programming, probably one of the ones that I tend to think about a lot nowadays is Kernighan's law. So Kernighan's law basically says that debugging code is twice as hard as writing it. So therefore, by definition, if you write your code in the smarter way as possible, you are not smart enough to debug it.
Right.
And I don't know if this is just because I'm getting older or if it's because I work on a lot of open source projects, so I have to do a lot of context switching. But increasingly, I really kind of felt that message, which is that actually think about your future self when you're coming back to this, or to the contributor who wants to jump into your project, who's maybe new to the language or the platform or whatever. And it's not about being smart or clever. It's not, unless you're doing something, ultra specialized, like chipset optimizations or something. Much of the time, it's about creating a sensible abstraction of the system that you're working with. And nothing makes you feel less smart or clever than that really cool trick that you put in there, or all these abstractions when you're trying to unpick it a year and a half later and work out what's going on. So that one, when I saw that there was a name for this, kind of like made me laugh. And I thought, yeah, that's funny. Debugging is twice as hard. And I have looked at my own code through the debugger and just gone, what's happening here? How can this be happening?
Yeah. Absolutely. So this law, quote unquote law, comes with an assertion, which is that debugging is twice as hard. And maybe it's an understatement. Maybe it's 3x, maybe it's 4 times as hard. But I think we definitely spend more time debugging than writing when it comes time to do that. And it kind of goes back to read versus write. You write it once, you read it many times. Sometimes you rewrite a little bit, but we spend more of our time reading the code than we do writing the code. And so just like we spend oftentimes more times debugging the code than we do writing that initial implementation. And I love the way that he uses the word clever there, because it really does make you feel clever when you come up with a solution to a problem that requires like a sidestep or like a special use of the language that and maybe not everybody knows. And maybe you'll forget it later. You won't even know that trick later. Or you just learn some sort of esoteric aspect of your favorite programming language to use that to solve your problem. Feels really good. And a lot of times, like, that's the stuff that we programmers love. Like, ooh, I came up with this clever solution. But it turns out that the actual smarter solution, not as clever, but the smarter way of doing it, because of this knowledge of I'm going to be reading this later, or I'm going to be debugging this later, is there a more straightforward way of accomplishing this? Can I remove the cleverness? And that requires a humility to say, yeah, I'm smart enough to do this clever trick, but actually I'm smart enough to know that I should not do this clever trick if I can avoid it. And if you can avoid it, your code is much more useful.
Or at least leave a couple of comments in there. If you're going to do something cool, like, yeah, I'm not going to multiply this by 2, I'm going to bit shift instead.
Exactly.
Or whatever it might be. Although, interestingly enough, this law was one of the ones which generated the most heated debates, I think, on Reddit when they published this, because a lot of people said, and I think quite fairly, that, well, to their minds, clever code is code which is simple, which is elegant. The clever code is the code where someone has avoided unnecessary abstractions or whatever. So I think that's a fair counterpoint.
Yeah, maybe tricky might be the way to think about it. Like when you're pulling your tricks out of your rabbit out of the hat, that kind of code is the code that can become problematic.
Yeah, absolutely. And then in terms of, I suppose, the world of consulting, there's lots of laws that are to do with organizations, and I'm sure we'll talk about them. But one that I think really sticks, and I do talk about this with clients and with engineers regularly, is actually Goodhart's law. It's a statistical law, but in its kind of simplest form, it essentially says when a measure becomes a target, it ceases to be a good measure. And the reason I find this one really important is when you're doing consultancy work, you're often maybe like involved in changing things, changing how organizations work or building new things. So of course, people want to measure, are we doing things well? Is what we're doing, making people more productive or less productive? And that's great. And that's natural. And that's good. We want to measure and make sure that the changes we're making are overall having a positive impact. Mm-hmm. But in our desire to do that, we can sometimes kind of go too far and actually cause problems. And I hear this a lot from people when they say things like, how do we measure engineer productivity?
Right.
And then my kind of answer is, well, Basically, you can't. You can try and use metrics like lines of code per day, or you can try and use metrics like average time to close a pull request or whatever. But the problem is, as soon as anyone knows you're measuring that, they're going to also know that to a certain extent, you're using this as some kind of target. And the smartest people there are just going to game the system. So if you start measuring how many bugs are attributed to an individual developer, and developers will stop working on complex code. Or if you're going to start saying that, productivity is equal to the number of lines of code changed, you're just trivializing the fact that you can spend 2 days debugging the system and make a 2 or 3 line change, which has an enormous impact. And you find this all the time in organizations with things like KPIs, where if you put them in place, you've got to be very, very careful, because if they do become targets, it's then easy for people to try and game these targets or feel threatened by those targets. Are these being used to rank me or monitor me? And actually, it's sometimes used this to a certain extent in defense of engineers and say, well, it's very difficult to measure the productivity of a craft. And this comes down to something which is in many ways still a common misconception about software engineering. Software engineering is not like an assembly line where you can measure the productivity of certain systems and their efficiency. It is much more like a craft. It is an intellectual activity. And those kind of activities are very hard to measure. And you wouldn't necessarily say, how can we measure the productivity of every ideation meeting we have? You wouldn't even consider that, because you understand that this is more abstract intellectual exercise.
I had a similar situation back when I did contract development, with people asking for estimates around building out of an application. And I would always tell them that the closest thing, these are non-technical people who are trying to get a business started or try to build an aspect of their business. And I would say the closest thing you have to understanding the software development process is like building a house. But that metaphor fails in so many ways that if you think that it's like building a house where we can lay out the design of the house and we can lay out how many stories and how tall the walls are and all the details of the house, and then you can go out and get a materials list, and then you can go out and get subcontractors, and you can pretty closely come up with a budget for the design of a house, especially if it's a cookie cutter house, but even a custom home. Here's the plan. Here's what these parts cost. You can take off a room, save this much money, etc. Like, that's the closest most people get to understanding custom software. And it falls apart almost immediately because we don't have the design of the house, right, in custom software.
Absolutely.
All that we know is we don't have that at all. And so estimating what's our price for this project at the outset is a fool's errand. It's actually, I believe, impossible.
Yeah.
And so I'd have to explain that to people. And that's a tough pill to swallow when you're trying to say, can I afford to build this software? But it's just the facts of how it works.
Yeah, for sure. It is a tough pill. It's very difficult to say to a client, I can't tell you how much this is going to cost, because I can't tell you how complex it is.
Exactly.
Because I won't know until I know more about the domain. And then when I know more about the domain, I'll be able to say, well, there are certain parts that are more complex than we expected, and you can choose to have them, with the associated cost, or take them away. So why the word architect is a really strange word.
Yeah.
Because most architects don't really do architecture. Architecture is about designing something where the end state.
Yep.
I always think of software architecture or systems architecture or enterprise architecture. It's a bit more like SimCity. Like, you set up industrial zones where you're going to have like access to lots of electricity, or you'll set up super highways close to the airport. You're kind of like planning for growth. You've got a certain idea of where you want to put things to keep things in a certain order and how you're going to move around resources. But you're also kind of planning that things will grow organically as well within like certain areas, and just trying to do your level best to kind of gauge it right.
This This episode is brought to you by our partners at Algolia. Make every search lightning fast and deliver the results your customers want every single time. Algolia's search as a service and full suite of APIs allow teams like ours and teams like yours to easily develop super fast search and discovery experiences. And best of all, and this is what we love, Algolia obsesses over developer experience. Their mission is to give development teams the building blocks necessary to create a fast, relevant search experience. And this includes extensive documentation and guides, an active community, and 24/7 support. Algolia is secure, it's reliable, and best of all, it's scalable. Get started at algolia.com and tell them Changelog sent you. That's ALGOLIA.com.
So of these laws, the one that I actually verbally say out loud the most, I believe, is Yagni. You ain't gonna need it. I say Yagni to myself or to others, even sometimes outside of the world of software. I'll just say the acronym to a friend and they'll be like, what? I'm like, never mind. Is you ain't gonna need it. And I think that it's so true in so many contexts. It's so easy to get into it, to get into the mix and start planning. And we just talked about how you don't really know, some of the system is emergent, right? Like kind of like city planning or like SimCity. And we build things that we don't need all the time. And again, it kind of goes back to the idea of the cleverness or the I know what I'm going to need later mythos. It just lets us down so often. And so many times we're just not going to need that thing that we're building.
Yeah, it's funny you said Yagni. When you were saying there's one that I say a lot, I was thinking it's got to be Yagni because it's the same for me.
You saw it coming?
And it must be the same for any other engineer who's ever had to work on a feature where they're just thinking, is anyone really going to use this?
Yeah.
Really? Or who's looked at their own code and thought, why have I spent all this time kind of like abstracting this away so that I can use a different kind of file system when I know I'm never going to use a different kind of, I'm never going to use like a different storage mechanism for this whole thing here that I built an abstraction there for. I didn't need that.
Oh gosh. Let me throw my friend Nick Nisi under the bus, who is a good friend and a good engineer and a JS Party panelist. We're working on some software around JS Party's game show. We have a Jeopardy style game show called JS Danger. And we built a web app so you can actually, have a game board. And in that web app, you have the contestants and they have their faces, right? So these are the three people who are the contestants and we put their avatars in there. And I built the first version of things. I was like building out the JSON structure of how we're going to load this data as we can reuse this game board. And I just go out and I figure, well, we'll just load a URL and make an image source, So I just go out to their Twitter profiles and I right click and I can't remember if I download the file or I just grab the URL and throw that into the JSON blob. Then I pass it off to Nick to continue working on this. And he decides that instead of just a string, which holds a URL to an image, he's going to have like a handler function, which does something else. And that way we can just like put their avatar or their Twitter name in, whoever it is, and it will go determine whatever their actual current photo is and all this kind of stuff. And then, total Yagni, by the way, we're going to use this game board like once a month, once every few months. And we know the contestants beforehand, and it takes about 30 seconds to go grab those URLs. But a dynamic lookup was nice, even though Yagni, until something changed in Twitter's API and the CORS rules or something. Anyways, he couldn't deterministically figure out what the URLs were anymore. And so then he had to write a proxy server in order to resolve the actual URLs of the avatar images and get a token and all this kind of stuff. And so sorry, Nick, but I threw you under the bus there. We've all done it. He was just over-engineering a thing that it was total Yagni. And he had fun doing it.
There should be like an extension to the law, which is like Yagni, but I want to code it.
Yeah, exactly.
Sometimes I realize that that's what's going on with me. Like my dot files on GitHub, I get a new computer like once every 5 years. Yeah. I don't know why I go to the effort of trying to automate all the setup of it. And it is total Yagni, but
Yeah.
it's also kind of like, I just kind of want to do that.
Right.
And yeah, sometimes I find myself doing that, thinking, am I writing this because it's actually useful, or I just think it's cool to have that handler function that can do this? But look, guys, we can also do X, Y, Z.
Right.
Yeah, we can, but no one needs us to.
Right. Which, I mean, if it's for pure joy and it's on your own dime or your own time, I'm totally cool with it. I feel like the lazy part of me is probably the one that says Yagni the most, because I have these two battling things. Like I have the desire to build cool stuff and to think ahead and be smart, but I also have this desire not to do extra work. And so that, what I'll call lazy programmer, is the one that usually says Yagni, because the one that gets going is like, oh yeah, and then I'm going to do this and that. And then I started thinking like, do I want to actually build out all these things? No, I don't. And so I usually say Yagni.
And again, I think this is where it's interesting seeing how the laws play off each other a bit, because we've already spoken about the Pareto principle, but that applies here as well, which is that, it kind of is Yagni, which is that 20% of the features are going to be used 80% of the time.
Absolutely.
The vast majority of the features you're developing for an application or a solution or whatever, well, it's like a hockey curve or whatever. So a small number of core features, the 20%, are going to be used extensively. And then there's going to be a whole bunch of stuff that's not used at all.
Mm-hmm.
Or maybe just not used to the extent that justifies the effort involved in building it. And then there are those exciting moments when you're kind of whiteboarding or starting to put something together in the editor and you're thinking, yeah, this is cool. And I could extract this into some kind of interface or plugin mechanism.
Right.
And it's those moments when you kind of have to stop and think, yeah, but am I actually going to need to do this? And if I do this, is this going to be one of those projects where I registered a domain name and
exactly
kind of never got any further?
Right. But one argument towards Yagni, even if you aren't going to need it again. So I did a show with Saul Ponson recently, and he wrote VisiData, which is a very complex tool for visualizing data inside of the terminal. And he said, if this was just for me, I don't need all of this, but I want to have something nice. And so what I do is I open source it. And now it's worth all my effort. It's worth all the stuff, even if there's things that I'm not going to need again, because all these hundreds and thousands of people can benefit. So one thing that my Yagni brain often misses out on is the opportunity of providing an abstraction that other people are going to use. I don't think in reusable libraries that I can open source as independent little things very often. Often I'll look back at code and be like, holy cow, this is a library right here. This could be an open source project. But some people think that way. They think, well, maybe I'm not going to need this function again, but other people might need it. And so I'm going to actually take the time to build an abstraction, put some documentation together, and release it as open source. And now, even though Yagni, for me, somebody out there is benefiting. I think that's a nice counterpoint to that principle.
Yeah, absolutely. And that's that kind of open source mindset of, if I share it, then it could also grow on its own as well. It could get better.
Yeah.
I suppose a counterpoint again to that as well, counterpoint to the counterpoint would be, you can design it for open source and you can design it for other people to contribute to it with a plugin mechanism or whatever. That kind of reminds me of another law, which I think is really, really important in software design, which is Gall's law, which basically says that a complex system that works is invariably found to have evolved from a simple system that worked. So basically, complex systems are not created as complex systems. They start off as simple systems and they evolve over time. And the example that often gets used is the internet, which started off as a way for academic institutions to share data. And then, it's become what it is today. But you could look at things like Kubernetes as an example. It probably started off life. Well, of course, it started off life much more simple than it is now.
Right.
And all of these extra features and abstractions for storage systems and different container interfaces and so on, they kind of got added on over time as needed. But initially, they weren't there as abstractions. They evolved.
Mm.
But who knows? Because then if you just kind of let different people contribute in different ways, you also run the risk that you lose coherency and different people have different ideas about how things should be pluggable or extendable, and you end up with a project that's no longer internally consistent. So I guess you also need to kind of make sure that when it is evolving, at least it's evolving with a set of principles or patterns or whatever, so that it still makes sense to people.
Yeah, so if you do set out to build a highly complex system, I guess what is the takeaway there? It's that you start, like, you have to break it down into a series of not complex systems, right? Like, you need to somehow get to a point where your starting place is not complex. Because if you design a highly complex system, according to Gall's law, that's going to fail.
Yeah.
But if you know that the domain at which you're tackling is highly complex and there's no way of actually getting around that, you need to break it down and you need to be able to build some sort of a simplistic either representation of that system to start from or subsystems, which can be simpler in order to build a more complex system that can evolve from them.
Yeah, and I think that's exactly it. If someone had to create, for example, Kubernetes right now from scratch, and they were basically given the APIs and said, this is a specification of what we want and how we want it to work.
Yeah.
But we're not going to tell you anything about the internals. And we're not going to tell you anything about what's been happening in software development for the last 30 years. There would be an enormous challenge for them because, kind of, as you said, it's made up from smaller systems that have then been proven to work. Like under the hood, there's etcd, which is its distributed state management system. But distributed state management is really, 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 really complex. It has all sorts of challenges. And there's some of the laws in the repo about that as well. But they didn't invent that from scratch. They used an existing proven system. I think
Right.
etcd is based on a Raft protocol, but I'm not sure. But anyway, they took an already proven mechanism for kind of consensus-based representation of state in a distributed system and then plugged that in. And then they took existing systems like, volumes, file systems in Linux, whatever it might be, and kind of composed it together from that. It wasn't like every part of the system was created from scratch.
That actually plays into what I'll call an interpretation of Hanlon's razor. So Hanlon's razor is never attribute to malice that which is adequately explained by stupidity. I've also heard that as incompetence versus stupidity, if we're going to start to mince words there.
Yeah.
Which I think is a great thing to fall back on. I think it's a gracious way to writ large approach people and life, is to think that probably this was not ill will, but probably this was incompetence or stupidity, whatever the situation happens to be. Now, it's not always that. It could be ill will, but if you start with that assumption that people are generally not against you, but happen to be incompetent or make mistakes or stupid, then you go from there, and it's a much better way to live one with another. But I think the interpretation of that, or a slight change of that, which applies to this complexity situation, is that a lot of times we attribute stupidity to the programmer that came before us, and in a malicious way, right? Like this person either didn't know what they were doing, or they left this mess on purpose, or whatever we have. There's always like the previous programmer scapegoat a lot, or the one that you're blaming whatever situation on. And I think the way that you can slightly change that in a positive way is that don't attribute to stupidity that which can be explained by lack of information, lack of context. Because the person that made that decision, which no longer makes sense or is confounding, a lot of times they weren't stupid, they weren't malicious, they just didn't understand the system yet, right? Complex systems evolve over time, and they evolve as more information comes into the game. And so a lot of those decisions actually were the best decision at the time. It just didn't scale.
Yeah. And also a lot of decisions just have to get made, sometimes quickly.
Yeah.
And sometimes without as much time as you would like to take the decisions. And I think part of this is, I suppose, an emotional maturity thing. I think you learn it slightly as well when you've been around long enough to have been sitting around at a table and someone just absolutely shredding something to bits and saying, what was this person thinking? It's like, I was looking at this thing, total amateur hour, like, what were they doing? And you're sitting there thinking, how long before I have to tell them this was me? And I thought it was the right thing at the time. And I get it. I understand that it wasn't that smart. But at the time, I didn't know what I knew now, or I didn't know it would be used in this way. So I think that is a good one. I think it's just also an important one as well. I think technology can sometimes be a little bit of a harsh word for this, that we just need to be kind and inclusive towards each other.
Yeah.
You can see amazing things in the world of open source in terms of, like, say, for example, the time people spend contributing to projects for no other reason than they just think that they're cool, they love them, and they want to support them and give them their time. And that's wonderful. And you can also see people just kind of rip stuff apart to try and show how clever they are. And we all grow and we all learn, and we tend to learn and grow the best from people who are inclusive. And when we make mistakes, look at those and say, hey, instead of tearing it to pieces to show how clever you are, say, maybe we can look to this together, and I've got a few suggestions, and kind of like guide that person through that.
Yeah. It's easy to forget that there's a human on the other side of that text area, because it's all text-based communications, and because all of the cruft and all of the stuff of life that you're bringing to your laptop today, and I'm halfway around the world, and I got all my own stuff that I'm bringing, and we're just typing into a thing and hitting submit or send. And we see an avatar, maybe it's a picture of your face, but maybe mine's just a weird green blob representation of me when I was, 18 years old. And so we tend not to give people the benefit of the doubt on the internet. That's one of the reasons why I've always loved podcasts, and one of the reasons why, honestly, we get way less blowback on things that, we say that are stupid on our podcast, or like whatever, misrepresentations or whatever happens to be, because there's an empathy with voice that lacks without it. And people just give podcasters that benefit of the doubt because they can tell this is just a person talking. Like, I can hear their voice, there's inflection, you can hear doubt even if you're saying the words, whereas if you just type the same exact words out, like, that's removed. And a lot of the malice and the way that we treat each other online, I think, is because we're just so abstracted away from the human on the other side of that text area. And if we just was more aware of that and thinking about that, and thinking, how is this going to affect this person's day? Like what I say about their open source project or whatever it happens to be. Well, I think that we would all be a little bit better off.
Yeah, absolutely.
But it's hard. It's hard to remember that in the moment.
It is hard. But I think that's a really important thing. And as work becomes more distributed and teams become more distributed, those kind of things are more likely to happen. I mean, I found, again, through consultancy work, having to work with different teams and so on, one thing I'll often suggest on engineering teams that I'm working on, particularly if we've got a mixture of people, maybe contractors, different organizations who have kind of all been thrown together, is when you do your pull requests, look over the code, take your notes, but then go and sit down next to the person and talk over them together. And that was something I learned after really just, seeing the occasional incident where someone would write something and either maybe they were trying to be funny and, the sarcasm they were using didn't come across in text, or they were just having a bad day and didn't do exactly what you said, which is think, there's another person on the end of this who's maybe also having a bad day. And actually, instead asking someone to say, take the notes, and they can be constructive criticism. It's sugarcoat things, but then go and sit with them and have a chat about it and make it more of a two-way dialogue. And then you get that more empathic conversation that's happening. And you'll probably both get a lot more out of it as well.
I'm Jerod Santo, GoTime's producer and a loyal listener of the show. This is the podcast for diverse discussions from around the Go community. GoTime's panel hosts special guests like Kelsey Hightower.
And sometimes you can leverage your cloud provider and make margins on top. That's just good business. But when we're at the helm making the decision, we're like, yo, forget good business. I'm about to deploy Kafka to process 25 messages a year.
It's nerd pride, right?
Picks the brains of the Go team at Google.
You don't get a good design by just grabbing features from other languages and gluing them together. Instead, we tried to build a coherent model for the language where all the pieces worked in concert.
Shares their expertise from years in the industry.
Don't expect to get it right from the start. You'll almost definitely get it wrong. You'll almost definitely have to go back and change some things. So yeah, I think it goes back to what Peter said at the start, which is just make your code, write your code in a way that is easy to change, and then just don't be afraid to change it.
And has an absolute riot along the way.
Yeah, you know that little small voice in your head that tells you not to say things? What is that? How do you get one? You want one of those? Is it like an in-app purchase?
It is go time. Please select a recent episode, give it a listen, and subscribe today. We'd love to have you with us. All right, Dave, hit us with another law.
Okay, so I'm going to butcher the pronunciation, Hofstadter's law. So apologies to anyone who can pronounce the word properly. It always takes longer than you expect, even when you take into account Hofstadter's law. I think this one is great. It always makes me smile.
Yeah.
It makes my colleagues smile when I say it to them and say, basically, the law is that it's always going to take longer than you expect, even though that you know it's going to take longer than you expect.
You just can't avoid
Somehow,
it. Self-awareness does not matter.
Still, it's going to take longer. And I love it because it applies to software development, but it pretty much applies to everything else in life as well.
Yeah.
I don't know if that's because we're naturally optimistic creatures or something like this, but things just do take longer. There's just always that little bit of complexity that you start to unravel, and you look at it and think, oh, this is going to be something that's I'm going to lose an hour, working out what's going on here.
Right.
And then 4 hours later, you're like, oh, I've actually moved backwards. And then the day after that, you're thinking, I've invested so much time now. I've just got to at least get this fixed somehow. So that one always makes me smile.
Sunk cost fallacy, but yeah, absolutely. My boss, when I was doing my early days consulting, he would ask for estimates, because you got to come up with something. And his rule of thumb as a manager of developers was take the developer's estimate and then just triple it. And then you might be close. And I always thought that was ridiculous as a young man. I was like, seriously? Triple it? He's like, yeah. So if they say 6 hours, triple that. And there's your estimate. And it turns out you still undershoot sometimes when you triple that thing. And if you don't, then you just get pleasantly surprised.
It's funny you say that. I mean, I do that all the time. People will say, how long do you think it's going to take to do X, Y, Z? And perhaps one of the more junior people in the room will say, we can probably do this in 2 weeks. And then internally I'm thinking, okay, so this probably means it's about 2 months then, because I've been there. I know what it's like. And even my estimate of 2 months is probably way off.
Right.
And sometimes you see that shocked look on people's face, particularly perhaps more business-minded people, where they're like, really? And yeah, and I'm really sorry to say this, and I know it's a tough one to explain, but it is just going to take longer than we expect. Even though it sounds simple, there's going to be stuff that bites us. So either we just accept that and plan for it,
right,
or we go for optimism, but probably end up late.
Yeah, I think if somebody says this is going to take 2 weeks, I think at that point you have basically unbound risk, because it means they have absolutely no idea.
Yeah.
If they say 2 hours, they may be off, even by an order of magnitude. I guess it would be 20 hours. That'd be quite a bit, but they go to a day. But if they say 2 weeks, I can't think 2 weeks down the road on a software project. And I'm not sure anybody else can accurately on a recurring basis. Maybe you're right here or there. When I was still doing consulting and doing development hours, basically my smallest unit of time was a half a day. I would say, this is a half a day, this is a day. And the longest unit of time was 3 days. Anything bigger than 3 days, sorry, you have to actually rescope this and break it down into smaller pieces, because I cannot estimate more than that's much time in any sort of accuracy. Yeah.
And that's just being brutally honest with yourself about, the complexities of software development.
Yeah.
I think that's entirely right. And that's why in Agile, there's this whole idea of breaking down large stories into smaller stories.
Absolutely.
And until you really break it down to the task level where you're saying, how many chunks of my day is this going to take me? It's kind of just a big question mark.
Right.
And of course, that means you need tons of details to break it down to that level of granularity, which is why you can then get this kind of conflict sometimes with people saying, how long will it take to build a system that does X? And you're like, well, 18 months.
Right.
What is X? Or it could be 18 days if you just need something quick and dirty that fires a Lambda function, that kicks off a Lambda function, writes into a Google Sheets document. But what is X? And they kind of look at you as if to say, why am I getting this kind of attitude? It's it's just so hard to know. And neither of us actually understand what X means. Even if we spend 2 days writing a 70-page document trying to define what X is, we still haven't defined it.
Well, you get a few days down the road and X has changed because you have more information. And so now it's a moving target. One of my favorite things / least favorite things, eye roll or giggle, depending on how I feel that day moments, is when somebody announces a new product or service on Hacker News. Invariably, one comment, at least one, will say, I could build this over the weekend. Like, invariably. What's the big deal here? I could build this in a weekend. And I just have to think, you do not understand. You have not been writing software very long, have you? Because if you're just looking at, you could build a shoddy subgroup of the main functionality that only fits the part, the happy path and your particular use case in a weekend. And that's probably what this thing started as. A lot of products start off as a weekend hack or I just a proof of concept and I got it working. It's the 80-20 rule, sort of, right? You spend 80% of the time on the last 20% of the work, or you're 90% done, you only have 90% to go, kind of a thing. But we tend to definitely overestimate our skills and underestimate the complexity of these systems, which leads us to Tesler's law, the law of conservation of complexity. This law states that there's a certain amount of complexity in a system which cannot be reduced. So we talk about break it down and make it simple. And the cold hard facts is sometimes there's just no further down it can go, right? Like the complexity is inherent in the thing that you're trying to solve. This is one you said has resonated with you quite a bit.
Yeah, this one, when I read it, it really did strike me as quite profound, because I always love this idea, a bit like in mathematics, that you can sort of reduce and simplify and make things more elegant and eliminate complexity. But what I like about Tesla's law is it does kind of just state that the cold hard truth is that there comes a point where you ain't going to make that system any more simple. So the shoddy, you can build it over a weekend, 2 days project. Even that, if you look at it as a system overall, there's a ton of complexity there that maybe the coder hasn't put, but the complexity still exists for the systems administrator who has to kind of like wake up and then find a way to, restart the system late at night, or for the end user who has to kind of have a workaround or whatever else it might be. So of course you can eliminate unnecessary complexity if you've just done something in a way which is needlessly complex, but there will just always be certain things that you can't get rid of. Like
time zones.
Time zones are always going to be hard.
That's one that hits close to home for you and I, doesn't it? We had some scheduling problems because of time zones and the complexity of that system, right?
The show that nearly never happened. And in fact, one of my earliest software development projects, I was working on chipsets and device drivers, and we had to do some stuff around time zones, and it was extremely painful.
Oh, man.
But yeah, going back to the conservation of complexity, there are some things you just can't avoid, like say time zones, or like financial transactions in software, or transactions that you really have to be absolutely certain have happened. It's pretty much impossible to always be certain 100% of the time that you hope to have done, say, for example, a funds transfer or whatever. So whether you deal with that complexity by having an end of day batch process that does some checks and balances, or a dead letter queue for failed messages, or, something like a modern system like Kafka where you've got retry topics or whatever else it might be, there's just no getting away from the fact that if you're trying to send a message from A to B, it's an inherently complicated thing to do in the world of computing, and that you can't just magically wave a wand and have a solution that makes that complexity go away.
Absolutely. I was thinking about time zones again, and a funny joke people made around recent advancements towards Mars is that the problem with going to Mars is we have to add a new time zone, and the complexity that comes in when the time zones. The thing about time zones is they're geopolitical. I mean, there's certain, they wrap around cities, they change because of politics. They're really complex. And the reason I bring that up is because sometimes the complexity comes not even necessarily in the domain, but the fact that your software exists over a time span. And it has to apply in the current time span, not time zone. But the world changes, right? The complexity might be that the ground is swept out from underneath your software over time. So you may have handled the complexity that was in front of you, but you didn't actually account for the complexity that was coming your way. That's an incredibly hard thing to do.
And I mean, it's kind of getting you coming and going here, isn't it? Because if you look at things like all the panic that there was about Y2K, well, the panic came from a classic Yagni, which was people probably rightly saying, we don't need to like use more than 2 digits to represent the year. Like if anyone's still running this software 30 years from now, the world's already, in a lot of trouble anyway. So don't worry. Don't worry about, dealing with the millennium.
Was it Bill Gates that somebody said like, who's ever going to need more than like 48 kilobytes of memory? I can't remember what the amount was or who said it, but it was that exact kind of naivety of who's going to need 4 digits to represent the year.
And it's like, this is the challenge, isn't it? We just don't know. Do we just use a time zone library, or are we flexible about time zones? And like you said, it can be a geopolitical issue. Time zones can change.
Daylight savings.
Even, time itself can be changed, and with daylight savings and stuff like this. And trying to engineer that into systems with the flexibility to incorporate that change could be hugely time consuming. And then you've got to do that balance between, do we need it? How badly is it going to bite us?
Well, that plays nicely in one of my other favorite laws, which is Murphy's Law, which doesn't apply strictly to software systems, but certainly applies to software systems, which is that anything that can go wrong will go wrong. So I am a card-carrying pessimist. I like to think that I'm a realist, which makes me maybe an optimistic pessimist, but I tend to think about what's going to go wrong. And I think that makes for a pretty good software developer, even though your code can sometimes get more complicated than it needs to be because you're accounting for things. But I've just lived long enough to know that, Murphy knew what he was talking about. And if something can go wrong, it's probably gonna, and you better be ready for it.
Oh, yeah, absolutely. And it could be when you're, looking at a pull request and thinking this certain section of code, when I think about it, I'm not convinced that's thread safe. But it's never really going to happen that we get a context switch at this time or whatever.
Right.
But no, it will happen. And when you're up late at night trying to fix this issue, that's definitely one that you'll be remembering.
Yeah.
And I think kind of having that healthy, skeptical view to things breaking is really important. And I suppose plays nicely into a law that I added recently, which is, I suppose, a bit more kind of academic. I realized is super important, which is fallacies of distributed computing, which is, I'm going to have to look through my notes to get some of the best examples. But essentially, when we're programming, we often kind of just assume that we can do like a remote procedure call. And we know that under the hood, there's some stuff going over the wire. But the fallacies of distributed computing are that the network is reliable and that latency is 0. The network is secure. Topology doesn't change. There is one administrator. And this kind of is a bit like Murphy's Law, because basically Murphy's Law is like, well, we know there's these fallacies when we're doing anything that's distributed. Things can go wrong. Things can change. People can, change servers around or remove something from the rack, gives them a new IP address. We can get weird latency issues. And if the software is running for long enough, we'll definitely find those issues one way or another.
Mm-hmm. Or sometimes you'll never find, you'll hit them, but you'll never actually be able to understand because of the infrequency of it. So here's a small example. We have a bot in our changelog Slack that posts when we publish a new episode, and it's integrated into our system. And we publish a new episode maybe 5-6 times a week, but it just posts in there, hey, new episode of Brain Science, here's a link to the Slack community. And about once every 4 or 5 months, it posts it twice. Boom, boom. Now, in the scheme of things, this is a good problem to have, right? Because, it's not a big deal. Everybody in our Slack channel is like, yeah, funny, Jerod can't code. And I'm probably never going to actually get to the bottom of that because it happens so infrequently and it's so small stakes. How would I even go about debugging such a thing? And I don't care enough to do so. Of course, I could probably find out what's going on there. But yeah, computers are hard, especially in terms of distributed computing. Networked computers are extremely complex.
Oh yeah, they are such a pain. Life would just be so much easier if people did not network things together.
Yeah, we just play solitaire by ourselves.
yeah, why did anyone ever come up with networking compute? Let's just build bigger mainframes and run everything on one big mainframe. That would definitely make life easier.
Well, we're getting close to the end of our time here. Any big ones that you had on your list we haven't talked about? Of course, we're not going to be comprehensive. We'll link up all of these laws we've talked about, and we'll also, of course, link Dave's Hacker Laws repo so you can go read them for yourself. But maybe one or two more real quick, and then we'll call it a day.
Maybe one that's not in the repo yet. I'm still considering this one because just like any larger project, when you get a number of contributors, people come up with ideas, and it's difficult to kind of know where to draw the line between, is this something that you can reasonably say is a kind of roughly well-known principle, or just something funny something's come up with, which might become a principle someday.
Yeah.
But I did hear about something, and it was when you talked about Murphy's Law that it tweaked my memory, called Schrodinger's backup, which I thought was great. And Schrodinger's backup basically says the state of any backup is not known until you restore it.
I like that one.
Because if you've ever done any kind of disaster recovery type stuff, that is exactly the case. Until you've tested that backup, until you've actually restored it, you don't really know. And you can dry run things and you can test things out, but there's always that uncertainty there.
That's great. I do like that one.
It ties nicely into Murphy's Law as well.
Absolutely. It reminds me of how I think about backups, which I say sometimes is that nobody actually wants backups. Everybody wants restores. The backup is just a liability, actually, right? It could be a data breach scenario. It could be wildly wrong. It could be outdated. It could overwrite things that are valid. There's all sorts of things that can go wrong with backups. And if we could just skip backups altogether, we would. But what we really want is the restore. And so backup is kind of a means to an end. Restores is what we're after. So make sure you can restore that backup or it's completely worthless. That's Schrodinger's backup right there.
Yeah, and if you search it on the internet, you'll probably find a Reddit thread with some horrifying stories of people who've had terrible experiences. Another one, which I think is going to come in soon, is the Box Law, which comes from statistics, which basically says that all models are wrong, but some are useful. And there was a bit of discussion about whether this is valid for software development or not. But the discussion kind of came to the conclusion that it is. It's actually very similar to Joel Spolsky's law of leaky abstractions, where he says that all non-trivial abstractions to a certain extent are leaky. And I think these two are kind of essentially saying the same thing, which is that, well, when we're doing any kind of software development, we're modeling a system of some kind. You know, we're trying to create some kind of abstraction that represents something like a network or a train timetable or whatever it might be. And of course, it's only an abstraction. There are going to be, you know, mistakes with it, simplifications. There have to be, because to reproduce it in its entirety would be too time-consuming and complex. But it doesn't mean that it's not useful. And I guess to a certain extent, that's where some of the whole idea of the craft of software engineering comes in. It's like, how do you draw that abstraction? Where do you draw the line? Where do you stop? Where do you say we need more detail? And it's a process that I guess we're kind of always learning and hopefully growing on that one as well from our experiences.
Yeah, it seems like we're still in the phase of like, is it an art? Is it a science? We can't yet call it a science because there's not like hard, fast. There's these rules and there's idioms and there's practice, there's best practices, but it's not like civil engineering where we can just plug in all the numbers and do the math and say with like 99.9% certainty, yes, this bridge can hold that weight. You know, that's a science.
Yeah.
And we aren't there yet because it's so emergent and so figuring things out as we go. But I feel like we're on our path to that, hopefully, maybe someday.
Yeah. But so many parts of it are changing. Even today, a colleague was saying, you know, we've got our systems running 20% CPU utilization, 20% RAM. Could we halve the number of systems? And he was saying, like, in theory, you could. You'd have to look at potential congestion at certain times, like peak loads and things like this.
Right.
But at some point, as you start to kind of constrain resources, you're just going to see weird stuff happen. Other things that you did not expect to be a problem will suddenly be a problem. Like suddenly you'll start getting disk issues, or you'll get some kind of network issues or something, because these systems by their nature are so complex. There's so much going on that, you know, we have the abstraction of like CPU, network, disk, RAM, whatever. But the physical processes that underlie all of this and the hardware that underlies it is highly complex. And complex systems, I mean, this is I suppose, chaos theory. But complex systems are systems which have wildly unpredictable results, even with quite similar inputs. You run the software on day one, it runs as you expect. Run it on day two, and you get something wildly unpredictable. And that was because of the time zone or whatever else.
Yeah, exactly. Well, we just touched the surface of these different laws and principles. I will submit to the listeners out there to check out these laws if you haven't heard of the ones we discussed. There are many others. And I think even just having maybe not intimate knowledge of all these things, but maybe call it practical or working knowledge, will make you a more well-rounded developer or software person, whatever your role happens to be. These are things that others who've come before you have found to be generally true, of course, maybe specifically false in specific instances, but useful nonetheless. Dave, this was a lot of fun. I really appreciate you joining the show and talking to me about these hacker laws.
Thanks, Jerod. Really enjoyed it. It's been great having a conversation. I also use the opportunity to thank the translators for the project. I've got a number of people who have just been tirelessly working at translating laws as they come in, which I'm just blown away by. I think that's fantastic to see. And also to shout out, a colleague of mine has started a podcast called The Venture, which is all about venture builders in Asia. It's quite cool. They've got some interesting people talking on that. So that might be one to check out if you're interested in building new ventures.
Absolutely. Hook me up with a link to that and we'll put it in the show notes. Links to all the laws discussed, all the things, we put them in the notes right there for easy clicking. So that's our show. Thanks so much for listening. We'll talk to you next time.
Thanks, Jerod.
All right, share your thoughts on this episode at changelog.com/403. This is episode 403. You can also open your show notes and click discuss on Changelog News. That'll take you right to the comments. And of course, huge thanks to our partners, Linode, Fastly, and Rollbar. They get it. Also, thanks to Breakmaster Cylinder for making all those awesome beats. And if you haven't heard, we have a master feed of all of our podcasts. You get all our podcasts in one single feed. It's the easiest way to listen to everything we ship. Head to changelog.com/master or search for Changelog Master in your favorite podcast app. You'll find us. Thanks again for tuning in. We'll see you next week.